In this video, we're doing related rates having to do with angles changing, which requires trigonometry. So please take a moment and read this problem. Thank you for reading the problem. So we've got a 10-foot ladder that's going to be sliding down a wall. So here's our wall, here's our 10-foot ladder, creating a right angle. And it's sliding down the wall, so normally we call that Y. And it's talking about the angle that the ladder creates with the ground. So we're trying to find how fast that angle is changing. So we're trying to find d theta dt at the moment, and it says when the base of the ladder is 6 feet from the wall. Well, the base of the ladder would be down here where x is 6. So let's go ahead and call that x is 6. Now what we know is the speed that the top of the ladder is going down the wall. So dy dt is equal to negative 2 feet per second. Now that's going to be a negative because as the top of the ladder slides down the wall, the distance is getting smaller. So now it's time to give a formula, and we know that y is the opposite side from the angle. 10 is the hypotenuse. Opposite over hypotenuse would be sine. So our formula would be sine of theta is equal to y over 10. Let's kill the fraction, multiply the 10 to the other side. We get y is 10 sine theta. Now let's go ahead and take the derivative. So dy dt is equal to 10, derivative of sine is cosine theta, d theta dt. Well, after the derivative is the time to plug in. So dy dt is negative 2. We have a 10. Now, cosine of theta, d theta dt. Well, if we go and look at the picture, cosine, remember, is adjacent over hypotenuse, so that would be 6 over 10. Well, now we can cross out the 10s. We can divide both sides by a 6. We get d theta dt is equal to negative 1/3. And since this is an angle in calculus, that would be radians per second. Let's try one more. All right, let's take a look at a second example. So everybody take a moment and read this example. Thank you for reading the example. So now we have a model rocket is launched 30 feet from Maria. So here is my lovely drawing of Maria. She's smiling and very happy. And she is 30 feet away from a model rocket. Here's my lovely model rocket. And that rocket's going to be launched up into the air. So we've got y is changing. As Maria watches the rocket go up, her angle of elevation is changing. So now we can go ahead and set up our problem. It says, how fast is the angle of elevation from Maria to the rocket changing at that moment? So we're trying to find d theta dt at the moment, and it says when the rocket has an elevation of 40 feet. Well, the rocket is denoted by y, so y is 40. What we know, our known rate of change. It says that the rocket is launched vertically at a constant rate of 20 feet per second, so dy dt is 20 feet per second. Now, since the rocket is launching upward, the distance is getting larger, not smaller, so we have a positive rate. Our formula, if we look at our triangle, we have opposite and adjacent, so that would be tangent. So we have tangent theta is equal to y over 30. Kill the fraction, multiply the 30 to the other side. Y is 30 tangent theta. Take the derivative. dy dt is equal to 30. Now, derivative of tangent is secant squared theta d theta dt. Well, now that we've done the derivative, we can start plugging in. Our dy dt was 20, so we have 20 is equal to 30. We have secant squared d theta dt. Now we're going to need secant. So let's come back over to our triangle here. So the distance from Maria to the rocket is 30. The height at the moment is 40. So that would make this length 50 by 3, 4, 5 triangle. Or you could go 30 squared plus 40 squared is c squared if you want. Well, secant is adjacent and hypotenuse. And it's actually going to be hypotenuse over adjacent, and 50 over 30 reduces to 5/3. Well, so now time to do just a little bit of algebra. I'm going to go ahead and divide the 30 across first. If I divide the 30 across first, I get 2/3 is equal to, square the 5/3, we get 25/9 d theta dt. If I kill the fraction on the right side by multiplying the 9 over, I get to 18 over 3, which is 6, is equal to 25 d theta dt. Divide the 25 across, we get d theta dt is 6/25. Again, it's an angle, radians per second.